These three objectives will be covered in two parts. At the end of this Part 2 video, you should be able to fully describe motion in terms of frame of reference, displacement, time, and velocity, calculate the displacement of an object traveling at a known velocity for a specific time interval, and construct and interpret graphs of position versus time. Chapter 2, Section 1, Velocity. Where an object started and where it stopped does not completely describe the motion of the object. For example, the ground that you're standing on may move 8.0 centimeters to the left. This motion could take several years and be a sign of a normal, slow movement of Earth's tectonic plates. If this motion takes place in just a second, however, you may be experiencing an earthquake or a landslide. Knowing the speed is important when evaluating motion. Average velocity is displacement divided by the time interval. Consider the car in Figure 1.5 on page 41 of your text or on the screen now. The car is moving along a highway in a straight line, the x-axis. Suppose that the positions of the car are x sub I at time t sub I and x sub f at time t sub f. In the time interval t is equal to t sub f subtract t sub I, the displacement of the car is x is equal to x sub f subtract x sub I. The average velocity, represented as v sub avg, average, is defined as the displacement divided by the time interval during which the displacement occurred. In SI, the unit of velocity is meters per second, abbreviated m over s. The average velocity of an object can be positive or negative, depending on the sign of the displacement. The time interval is always positive. As an example, consider a car trip to a friend's house 370 kilometers to the west, which is the negative direction, along a straight highway. If you left your house at 10 a.m. and arrived at your friend's house at 3 p.m., your average velocity would be shown on the screen now. This value is an average. You probably did not travel exactly 74 kilometers per hour at every moment. You may have stopped to buy gas or have lunch. At other times, you may have traveled more slowly as a result of heavy traffic. To make up for such delays, when you are traveling slower than 74 kilometers per hour, there must also have been other times when you traveled faster than 74 kilometers per hour. The average velocity is equal to the constant velocity needed to cover the given displacement in a given time interval. In the example on the screen now, if you left your house and maintained a velocity of 74 kilometers per hour to the west at every moment, it would take you 5.0 hours to travel 370 kilometers.
Suppose a car moves from point X sub I at time t sub I to point X sub f at time t sub f in the amount of time shown by the clock. The average velocity of the car is the displacement divided by the change in time. Since the car is traveling to the right, the sign of the displacement is positive and is equal to x sub f minus x sub I. The time interval is always positive and is equal to the final time minus the initial or starting time. The average velocity can be a positive or negative value because the displacement can be either a positive or negative value. Even though the motions of these two cars differ, at time t sub f they have the same average velocity because they underwent equal displacements in the same amount of time.
Velocity is not the same as speed. In everyday language, the terms speed and velocity are used interchangeably. In physics, however, there is an important distinction between these two terms. As we have seen, velocity describes motion with both a direction and a numerical value, a magnitude, indicating how fast something moves. However, speed has no direction, only magnitude. an object's average speed is equal to the distance traveled divided by the time interval for the motion. So, average speed is equal to distance traveled divided by time of travel. Velocity can be interpreted graphically. The velocity of an object can be determined if the object's position is known at specific times along its path. One way to determine this is to make a graph of the motion. Figure 1.6 on the screen now represents such a graph. Notice that time is plotted on the horizontal axis and position is plotted on the vertical axis. The object moves 4.0 meters in the time interval between t is equal to 0 seconds and t is equal to 4 seconds. Likewise, the object moves an additional 4.0 meters in the time interval between t is equal to 4 seconds and t is equal to 8 seconds. From these data, we can see that the average velocity for each of these time intervals is positive 1 meter per second, because average velocity is equal to the change in position divided by the change in time, which is equal to 4.0 divided by 4.0. Because the average velocity does not change, the object is moving with a constant velocity of positive 1.0 meters per second, and its motion is represented by a straight line on the position time graph. For any position time graph, we can also determine the average velocity by drawing a straight line between any 2 points on the graph. The slope of this line indicates the average velocity between the positions and times represented by those two points. To better understand this concept, compare the equation for the slope of a line with the equation for average velocity. You see that slope is equal to rise over run, which is to say change in vertical coordinates divided by change in horizontal coordinates. And we see that average velocity is equal to change in x over change in t, which is the difference between final and initial positions in each quantity. Figure 1.7 represents straight line graphs of position versus time for 3 different objects. Object 1 has a constant positive velocity because its position increases uniformly with time. Thus, the slope of this line is positive. Object 2 has a zero velocity because its position does not change, meaning the object is at rest. Hence, the slope of this line is 0. Object 3 has a constant negative velocity because its position decreases with time. As a result, the slope of this line is negative. Instantaneous velocity may not be the same as average velocity. Now consider an object whose position versus time graph is not a straight line, but a curve, as in figure 1.8 on the screen now. The object moves through larger and larger displacements as each second passes. Thus, its velocity increases with time. For example, between t is equal to 0 seconds and t is equal to 2 seconds, the object moves 8 meters, and its average velocity in this time interval is 4 meters per second, because average velocity is equal to 8 meters divided by 2 seconds. However, between t is equal to 0 seconds and t is equal to 4 seconds, it moves 32 meters, so its average velocity in this time interval is 8 meters per second, because average velocity is equal to 32 meters divided by 4 seconds. We obtain different average velocities depending on the time interval we choose. But how can we find the velocity at an instant of time? To determine the velocity at some instant, such as t is equal to 3 seconds, we study a small time interval near that instant. As the intervals become smaller and smaller, the average velocity over the interval approaches the exact velocity at t is equal to 3 seconds. This is called the instantaneous velocity. One way to determine the instantaneous velocity is to construct a straight line that is tangent to the position versus time graph at that instant. The slope of this tangent line is equal to the value of the instantaneous velocity at that point. For example, the instantaneous velocity of the object in figure 1.8 at time is equal to 3 seconds is 12 meters per second. The table lists the instantaneous velocities of the object described by the graph in Figure 1.8. You can verify some of these values by measuring the slope of the curve.
The first thing you need when setting up a sign convention for velocity is a defined axis system, with time along the x-axis and displacement along the y-axis. For motion in one dimension, velocity is positive when the object moves in the positive direction on the defined axis system. Since the position value is increasing, the graph slopes upwards. Velocity is 0 when the displacement stays constant. In other words, the position value does not change. This line has 0 slope. Velocity is negative when the object moves in the negative direction on that axis system. This line has a negative slope.
At this point, you should be able to fully describe motion in terms of frame of reference, displacement, time, and velocity, calculate the displacement of an object traveling at a known velocity for a specific time interval, and construct and interpret graphs of position versus time.